Okay, welcome everybody to the Microsoft IoT talk. We're very lucky to have Richard Jones from Microsoft here to do a talk for us about how he loves IoT, Internet of Things. Just before we start, I'd like to say that next month we've got to talk about apprenticeships by the BCS themselves and how the BCS is supporting apprentices to get through their qualifications and learn all about this wonderful IoT stuff, I suppose. So if you want to join that, please just get onto the BCS website and you can then have a link to Eventbrite from there on to join the webinar. Anyway, I'm going to stop talking and get more interesting things happening. So I'll hand over to Richard. Thank you, Richard. I'll switch myself off and over to yourself.
Super. Hopefully you can still see my screen and video if necessary, and you can all hear me. That's great. Thanks, Dave. It's a real pleasure to be here talking to you this evening. Thank you to you and your colleagues from BCS for inviting me along today. And the talk is about IoT at Microsoft. That's what I do. And this first picture is part of the Redmond campus, which is currently going through a big renovation, and we are making the building smart, pulling that data into digital twin and using that for all kinds of valuable insights. And I'm going to be talking about the technologies that we use as part of our overall Microsoft IoT strategy. So just a few words on me first. I've been working in IT for a horrifically long time, 26 years, and every day I've been doing Microsoft technologies. I've been with Microsoft now for 9 years and 5 years as part of the Microsoft IoT team. And going back, I don't know if the sort of the demographic and the age of the audience we've got here, but some of these things might resonate with you if you've been around as long as I have. And this is the kind of stuff I used to enjoy playing with when I was young. The little electronic set there. I persuaded the deputy head of my old school to sell 2 pet computers, the disk drive and the printer. So I had that set up as a network in my bedroom at home. The Commodore 64, which some of you may recognize, 64K of memory, and the laptop I'm using to talk to you today is 64 gigabytes of RAM. So 1 million times more in that period of 30 odd 40 years. Lego stuff there, projects at school, connecting things up to computers. At university, I did a project with a spectrometer controlled by a computer. So, computers and things, I guess, I've always had a fascination with. And in terms of the role I do now, I am a senior technical specialist in the IoT division. We're part of the Global Partner Services team. And one of the things I do really love about IoT is that I get to touch each of these areas that I've listed here, and you can kind of dive into whatever level you can learn more. There's always something more to learn. Of course, we all know that. But a lot of these areas here really, really interesting, really, really hot topics. And I've certainly done a lot of learning over the last few years. I didn't know that much about hardware and devices really, but I've certainly learned a lot over the last few years. And I do get quite a few toys to play with, and I'm going to show you some of these in the demos, all being well if the demo gods are in a good mood this evening, including the HoloLens as well. So I do have a HoloLens here that I want to show you, because that's really, really quite spectacular if you've never seen it before. And then we've got a Vision AI camera here and something called a Sphere module here again that I'm going to be showing you that. So lots of interesting things to play with and connect up. And also one of the things that I've loved about working in the IoT team is I've got to work with some really interesting partners who are doing some really, really interesting work with IoT. IoT is all about connecting up real world devices and machines, as we know, and using the data that's coming from that to generate actual business value and make lives better. This top left picture here, if any of you have ever done any CPR training, you will probably have done it on one of the mannequins from a company called Layerdal Medical. They've been producing these CPR mannequins for many, many years, and this model here is really the Rolls-Royce of mannequins. You can see that chest compression spring there. So the mannequin knows how hard you are pressing down for the compressions, knows the frequency you're doing it. The mannequin will respond with rolling eyes, making a noise. You can even inject it with drugs, and it knows what you're injecting into it from the specially coded syringe, how much is going in there. And they train whole crash teams, doctors and nurses, in emergency rooms using these mannequins. They're incredibly interesting. And for those of you who love your coffee, and if you're ever going to Starbucks, that machine in the middle there is a Mass Strainer 2 used in the Starbucks chain. And those have been connected up by the Azure Sphere device that I'm going to be talking about in a little while to help with predictive maintenance, et cetera, et cetera. And the top right one there, a company called Kongsberg I worked with, based in Norway, do a lot around shipping, intelligent shipping, autonomous shipping as well. And then another solution here in the bottom right, which is a sort of a people moving simulation with an engineering and architectural consultancy called Buro Happold. So really, really interesting technology, really, really interesting business use cases. So when we put these things together, it's actually really quite interesting and stimulating. So they sort of back down to earth a little bit in terms of to put this into context. And whenever we talk about IoT, we are talking about these two topics that come up that are key topics for us at Microsoft: intelligent edge and intelligent cloud. And it's nothing really new, because as long as cloud has been around, people have been wanting to run some workloads on premise. So it's really always been about operating a successful hybrid model, and IoT is no different. If we look at the big technology buzzwords associated with IoT, we're obviously interested in the different forms of connectivity between these devices and the cloud. When we run workloads on the edge itself, we call that edge computing. Artificial intelligence is, of course, the blanket term really that's used to describe any kind of classical machine learning, deep learning, and also reinforcement learning as well. And then the digital twins buzzword, which is the hottest topic at the moment. I'll talk about that a little bit as well. But every IoT solution is always a combination of these things. And the idea from us as Microsoft is that we want to make this as easy, as seamless as possible across the edge and the cloud to build a solution that's going to deliver the most business value. So here's the eye candy slide. And I thought I'd just jump straight into some of the technology rather than telling you the numbers of devices that are predicted from Gartner, etc., because yeah, we can accept there's going to be lots of them. So once you start to get over a few billion, I think you've made your point. We view IoT solutions broken down generally into three areas: the things, the physical machines and devices, and whatever you've got running from a compute perspective on the edge. And then as we move into the cloud through a cloud gateway and start to store and transmit that data, we start to build insights, of course. And then from those insights, we typically integrate with a number of back-end systems. That could be simple dashboards, maps, mixed reality, which I'll show you an example of later. Or Dynamics 365, a connected field service, where perhaps a machine over here is sending telemetry, an edge module is running some AI or machine learning algorithm and decides that machine is going into an unhealthy state or will be soon. That alert can be sent up, routed probably through the hot analytics path, and then a ticket could be raised in a connected field system to dispatch an engineer and go and fix that problem. They could go and take a HoloLens, get the telemetry, and get some remote assist while they're working on that machine as well. So this is kind of how we describe the digital feedback loop of all these components coming together and adding the business value. So let's start now to have a look at the edge itself. And I always describe the edge as a spectrum in terms of compute, because any IoT solution is going to compose a number of these different types of devices. From the left-hand side, we've got the most basic device really. It's not even, I suppose, a device. It's a simple temperature sensor or an actuator. That's probably going to be connected to one of these devices here that actually has compute and can connect to the internet. As we get into the more powerful compute, we at Microsoft start to call those edge devices, because we can run more advanced workloads, such as some of the AI and machine learning stuff that we've been talking about, all the way up to something at the end here, which is called Azure Stack Hub, which is your own Azure cloud that you can wheel into your data center and get the same Azure provisioning experience, but obviously within the confines of your data center. Depending on that workload, you probably want to be using, say, GPU or FPGA if you're doing a lot of deep learning for inference and scoring. If you've got need a very low cost device, you're probably using an MCU based device, and we've got the good old Raspberry Pi there that is very useful in proof of concepts, but we don't recommend using these in production. They're not really meant to be used in production, although you can now get more hardened and ruggedized versions that are more reliable, that are more suitable for actually running in production. And it really depends on the amount of money you want to spend and what your business case is. IoT's solutions are highly cost sensitive, especially when you're talking about many devices. So it's very important to justify that bill of materials that you're going to use on the device based on the business case and the return on investment that you're going to get. So a similar version of that slide really, but a bit more of a formal Microsoft one, starting to talk about some of the offerings that we have in this space. I will talk about Azure Sphere. We acquired a company called Express Logic, I think a couple of years ago now. So we've got now their real-time operating system called ThreadX, which is suitable for running on a number of different types of silicon, especially in highly regulated environments. That's where we see it used a lot, where you need that real-time sort of embedded behavior. And then coming across, we get into more powerful compute platforms. The device SDK is how you connect up to our cloud gateway, which is called IoT Hub, which I will discuss in a little while. And then into edge technology, when we start to want to run AI and machine learning algorithms, we obviously need a larger compute footprint. And then up into Azure Stack Hub that I've already mentioned, our Azure data center in a box. And then finally, the Azure cloud itself with all of these regions throughout the world, more than any other hyperscale cloud provider. And as I mentioned before, any IoT solution will typically be a combination of a number of these different elements. So thinking about security and the devices on the edge, a few years ago now, we released a research paper called The 7 Properties of Highly Secured Devices. And a lot of this work was based on our experience that we had gained through deploying Xbox devices. Millions of devices going out into the wild, getting hacked, getting attempted to be hacked. And of course, we wanted to protect the IP of the game studios, because we needed to give them confidence that their games weren't going to be stolen, their IP wasn't going to be stolen. And so the latest generation, I think starting with Xbox One X, had all of these properties. And what we said based on that was that in order to have a device out that's connected, it needs to have all of these properties in place. I'm not going to go through each of these in depth, but for example, hardware root of trust, absolutely critical. I'll talk about how that's used a little bit later on, but I would encourage you to do some research into this if you are interested in IoT devices. Now, in order to realize all of those 7 properties, you actually need a combination of 3 elements, and that is the hardware itself. So the hardware at a silicon level needs to be secure. The operating system that you're running on that silicon also needs to be secure. It needs to be updatable. And you need a service that is going to enable you to update, to do failure reporting, to securely send your applications down to it. And Azure Sphere as a solution is a combination of these 3 elements. So the silicon design, a secure operating system, and then a cloud-based service that does the health monitoring, failure reporting, and takes care of any updates for you. So the chip itself, for those of you that are into your hardware, interested in hardware, it's a system on a chip, and it's based on ARM cores. So we have 2 of the M4 cores there, which are connected up for real-time processing. You can install Azure RTOS onto those cores as well. And this Microsoft Pluton subsystem here, this is kind of the special sauce, if you like, that we've added to this chip design. That's where the hardware root of trust lives. You'll see that each of the different elements on the chip are separated by firewalls. You've got some flash and you've got some RAM there as well. And then we've got a Cortex A7, which is where that secure operating system is running. And that's where the bulk of people's applications typically runs. The initial chip came out, it just had Wi-Fi connectivity. Now we've added wired Ethernet, and there's also a company that's developed a module with cellular connectivity as well. So this sphere design is evolving all the time. Okay, so I've talked a little bit about Azure Sphere. What I'll do now is talk about the edge technology when you need to run more complex workloads, and all being well, I'll be able to show you a little demo of something as well. So let's go into IoT Edge. So you remember before I mentioned about the typical IoT pattern, where we have things, we have insights and actions connected up through this cloud gateway. And that works great when your devices are connected. You can process the actions and perhaps send information back to make the machine behave in a different way based on some tunable parameters. This, of course, becomes a problem if you don't have connectivity. If you perhaps can't have connectivity because of data sovereignty or high security, maybe it's because you have very unreliable connectivity. For example, you're on a floating vessel, you're on a ship, you're using SATCOM. The connectivity is perhaps very expensive, but also not reliable. What do you do then? Well, we need a way to be able to package up the workloads that are running the insights and actions and send those down to the edge. And we do that with a technology called IoT Edge. So in the example here, we've got a device with a video camera on it. Now that video camera could be doing, say, object detection or object classification. It could be doing quality checking on a manufacturing production line with a machine learning model, an AI model that's perhaps been trained to know what is good from a quality perspective and what is bad from a quality perspective. Now, clearly you don't want to be sending streaming video up to the cloud, especially when you've got hundreds or thousands of cameras. So we use IoT Edge for this. And once again, you'll see Azure IoT Hub there, our cloud gateway, which is used as the management plane for the technology running on the edge. So we've got a number of workloads here, one of which is Azure Cognitive Services, which I won't go into detail on, but there are a range of pre-trained AI models to do things like object classification, text-to-speech, speech-to-text, etc. A whole suite of modules that we've already pre-trained for you. Now, what we do, we deploy these pieces of code in containers, in standard Docker container technology. And we push those up into a container registry in the cloud. We put together a workload description in our IoT hub, and that's going to tell the Edge module what it needs to do and how it needs to wire these containers together. So that workload description gets pushed down, and then IoT Edge runtime will pull those containers down and start executing that workload on the edge without any connectivity. So what I'm going to do now, all being well, this is a starter kit that we released a while ago, and all being well, this is going to be running. So I'm just going to stop the presentation for a second, and I'm just going to pull up the media player here, if it's going to open. Just bear with me. And I had all of this rehearsed, but wouldn't you believe it? That don't think that wants to start. I don't know if maybe there's a clash with the GoToMeeting engine that's sort of stealing the feed from that. I think that's what's happening there, because that's definitely not starting. Okay, so assuming that I can't close the GoToWebinar stuff, because that would obviously put the that would stop the presentation. What I'll do is just show you this camera. Now, what that is doing, that is scanning its environment, and you would be able to see, if I could pull up the real-time video stream, that it was putting bounding boxes around me and recognizing me as a person, which is very reassuring. But what it's also doing is sending up that information to IoT Hub when it makes a match. So what I'm going to do is just pull this open, and all being well, my Altec camera here is working. And if I just connect to telemetry and then start. Okay, so hopefully you can see this. So I'm just going to zoom in there. You can see I've got some messages coming up here, and it's saying that it's identified a person with 86% confidence, 79% down there. So just imagine if, and let's just see if I've got any other signals coming in there. Let's see, person. So it's just person at the moment. I'll perhaps move that onto the cup to see if it can actually see something else there. Okay, no, it's just spotted person so far. So just imagine that these messages were, this is a good quality item, this is a bad quality item, this is a whatever type of object it's looking at. It could be used in safety scenarios. Is the person who's entered a certain zone wearing the correct safety equipment? For example, a yellow hard hat. There's all sorts of things that you could be doing with that. And again, that is all controlled through let's just blow this up here, through this IoT Hub. So here's my Azure portal. This is how I create all my resources. You can see that I'm sending plenty of messages up there from the device to the cloud. And if I go into my IoT Edge here, I can look at my Altec camera. And you can see here in modules, I've got this AI Vision Dev Start module, and that module contains the Docker container that's been built with that machine learning model in, with all those different object definitions and types that it's been trained against. And you can download that, you can have a play with that. And what I'm going to do is just pull this back up again, and I'm going to start from that point. So that kit is still available now, but what I was hoping to show you, and this is the way that timing works sometimes, I was hoping to show you this one because this has been announced recently, and it's the next generation on from that kit I've just shown you, and it's a combination of a compute module, a vision module, and also a sound module to do spatial sound analysis. And you get a better out-of-the-box experience as well. I was hoping to show you this one, but with a combination of COVID and Brexit, I think they haven't been able to ship this to me yet. So I had to show you the older version. It's a shame I couldn't share with you that streaming video. But I think, again, there was a clash there between the GoToWebinar and the media player there. But I will try that again just to see if I can get that working. So still thinking about the edge a little bit. Now, we do a lot of work with companies in manufacturing who traditionally have had very, very closed networks. They're probably running old versions of operating systems, Windows XP, Windows 7, even back to NT 351. Anecdotally, I've been told about from another company acquisition that we made just over a year ago called CyberX. And this is a technology that will plug into your network port on your OT network and start to discover all the assets that are sending traffic over the network. And they've built up a huge library of different protocols used by different, say, programmable logic controllers that you would find in these environments, whether that's Siemens, Rockwell, Allen Bradley, et cetera, et cetera. And so that's hugely valuable to discover what's actually out there and what's talking to what. And then that sensor will establish a baseline, understand what normal looks like. And then if something happens over and above that, it can alert you to say, look, I think there's some traffic here that shouldn't be occurring. And then all of that data can be sent up into the cloud and pulled into a central SIAM alerting system, management system for security incident and event management. We have one called Azure Sentinel, and we have a feed in from this, what's called the sensor that's plugged into the network. But then also for greenfield devices, newer devices that you can put an agent on, those can send telemetry from a security perspective up into Azure as well. So you can get a complete view across your brownfield and greenfield IoT estate. Right, okay. So let me just do a quick time check. Okay, so we're at half. Okay, so I'm romping through this quite quickly, so that's pretty good. Okay, so we've had a really good discussion about the edge. We've talked about all the physical devices that we might need on the edge and that we want to connect up. We've talked about making sure that we are secure on the edge. So what happens as we start to move into the cloud? The choice for your cloud solution really comes down to the age-old, do I buy something or do I build something? If you want to build something, we have a huge array of these IoT specific and related PaaS services, so platform as a service services, that I always describe as Lego bricks that you compose and build together with configuration and glue code to build your own solution. We have a number of partner solutions, huge companies, big names who have built IoT solutions based on all of these components. We also have our own solution, which is a software as a service offering called Azure IoT Central. And I'm going to show that to you as well. And I always describe that as Office 365 for IoT, because you stand up a tenant, you do some configuration, and you're away. You don't need to worry about much else. We also have a number of solution accelerators, lots of source code, lots of stuff on GitHub that you can use for reference to how to build your own solutions as well. So I've mentioned IoT Hub a few times, and IoT Hub is really one of the golden threads that connect all the conversations we have about IoT. It's our bidirectional secure cloud gateway that provides your device identity management and provisioning. Every device has got a unique ID and authenticates separately against the IoT Hub. There is a device to cloud send endpoint there that supports one of three protocols, the secure versions of HTTP, MQTT, and AMQP. And then we have a receive endpoint as well that looks a lot like an Azure Event Hub, because IoT Hub was originally a fork of the code from Event Hub, if you've ever worked with that. It's effectively, from this perspective, a queue where lots of data gets thrown in and you can pull the data out and then process it as you need to. We can also send information back to the device as well through the cloud to device endpoints. And we can also set up custom endpoints for those telemetry messages that are coming through. So we can send them to a service bus queue, we could send them to Azure Blob Storage, or send them to a different event hub. If we maybe wanted to section out the messages based on message properties and process them using different code that we might want to scale in a different way, or perhaps process at a different speed, as we mentioned earlier in that architecture typically known as the Lambda architecture. We also provide something called device twins, which is essentially a JSON document that's replicated between the device and the cloud and allows you to set desired properties and see what the reported properties back from the device are. We also give you a method where you can call effectively a remote procedure call in real time against a device that's already connected. And for us, I mentioned the IoT Edge device, for example. This is an IoT Edge device here, and we just treat that as a special kind of device with some extra properties. So effectively, an IoT hub, you have all your device endpoints facing outside onto the cloud, outside the cloud, and then internally, typically, you're going to have other Azure components on these service endpoints that form the back end of your solution. So one of the patterns we always talk about with IoT Hub is your ability to do device management. So I can set properties and tags on these devices. Those tags could be based on where the device is, some kind of logical grouping, and I keep those tags in the cloud. And that enables me to reference those devices through a search. I can set desired properties and push that down to the device, for example, a firmware version, to say, I want you, particular device, to be on version 1.8 of the firmware. The device can report back and say, well, I'm on version 1.5, in which case you might have code on the device that will be triggered from that variance in property, or call a direct method to say, right, I want you to perform an update now. And when it does that, that desired and reported property comes back into the cloud, and you can run queries and jobs at scale against that to ensure that all your devices are up to date, or identify the ones that aren't actually up to date and take the appropriate remedial action. Another one of the golden threads that you'll see us talking about is IoT plug and play. And for those of you that have been around long enough, you remember when Windows 95 came in and you plugged in a new device, and you got plug and play rather than having to preemptively install drivers. So a device would advertise its capabilities to the operating system, and Windows 95 would know what to do about it. This is our version of that for IoT devices. And you define a device capability model using a JSON LD schema, and you can do that in Visual Studio Code and set up all the properties, the commands you can execute on that device. And then once you've done that, that gets pulled into the SDK on the device, and then that will define what information is sent to IoT Hub. Another great part of this is that for device manufacturers, they can create all different kinds of devices, put the plug and play information up on this website, publish it. So when you come to say, attach your device to something like IoT Central, which supports plug and play out of the box, and I'll show you this, it's really, really easy straight away to build the dashboards, because they'll have the right properties of the telemetry and the commands that have been defined by this catalog. So it's a self-publishing capability model that's really, really powerful, and is really, really sort of lowering the barrier in terms of integration between device providers and solution providers. And then finally, you can run simulations based on those devices as well, because of course it knows what those telemetry values are going to be. So thinking about IoT Central itself, you can see here that this middle part of the solution now is taken over by IoT Central, which is our SaaS solution. Underneath the covers, IoT Central actually spins up 30, that's 30, individual Azure services that have been all wired together as part of the solution. And it does include IoT Hub under the covers. It does include Stream Analytics, which is our streaming analysis technology. It includes Time Series Insights, which is a time series database and visualization, as well as the device provisioning service, which I'll talk about in a little more detail later. The great thing about IoT Central is that although you get so much stuff out of the box, you can still extend it. You can export data. You can put in webhooks. So you can build an entire solution around it. It's pretty rare that IoT Central by itself is going to do all the job for you, but it's a great starting point, and it gives you an awful lot out of the box and really does accelerate that time to business value rather than building an entire solution from individual PaaS components, especially relevant for I think the smaller companies who don't have those huge development teams and 6 to 18 months worth of lead time for a project. And I am going to show you this as part of the demo as well later on. Okay, so what IoT Central gives you effectively, and you'll see some of this later, out of the box, the dashboards and a lot of different features and functionality to get you going pretty quickly. We take care of global scale for you, so you don't need to worry about those individual Azure services, how they scale, what happens from a DR perspective. This is DR ready, cross-region, so if we do experience an extended or catastrophic regional outage, then the paired region will spin up and you will get service continuity. Okay, so digital twins. Really hot topic at the moment. Everyone is talking about digital twins. What I want to do is talk about what we mean by digital twins from our perspective. To put it simply, Azure Digital Twins is a graph database, and you define the schema through an open modeling language called DDTL. Now, when I mentioned IoT plug and play earlier, that JSON-LD schema is actually a subset of DDTL. So these, again, forms a golden thread. We've defined the properties for our device. We can now use a superset of that language to define our actual physical environment. Because the key thing of digital twin, of course, is that you are modeling a physical environment. For example, it could be a city which contains many streets, many buildings. A building contains many floors, many rooms, etc. And positioned in those rooms may be some IoT sensors. But the real power of digital twin is to put those sensors and the values that they're generating into the context of a virtual model of the physical world. One of the key USPs for Azure Digital Twins is this open modeling language, the DL. And we're really seeing a number of different companies now being able to work together and collaborate because they're all talking the same language, where before in many areas in IoT, especially smart buildings, there was very much silos going on, which is understandable from a commercial perspective, because whoever owns the data owns the business value, can sell the insights. But that was holding back progress. And what we've started to see is companies being more willing to work together, as long as they can work through the commercials. There's a very much easier way for everyone to collaborate. So what we've got here, a quick example, we've got an ID of an entity we've called a station, which is inheriting from a room. So this extend is actually a type of interface inheritance. I'm sure many or most of you will be familiar with interface-based programming. This is an example of that. So then we move on to the live execution environment. So once we've defined the types of entities, we can actually create digital twins. So for example, a concrete instantiation of a room that has the same properties of a room type that we defined. And then we send telemetry into the digital twins. We can then start to raise events based on it. And we can also start to run graph queries across that model. So we can see for particular telemetry values how that relates to connected components, because of course, one of the key points about a graph database is the relationship between the different entities within it. You can send your telemetry data in from IoT Hub, no surprise. The front end of Azure Digital Twins is actually an API. We are working on closer integration with a lot of the Azure services, but you can put any data that you want in here. You can enrich it with external data sources, with asset management systems, etc., etc. And the Azure Digital Twin store becomes more and more powerful as you add more and more data into it, and keep adding that those changing property values from the devices in that environment. Azure Digital Twins stores the last known value for the telemetry values coming in. So you probably want to output that to do time series based analysis and build that up over a period of time. So we allow you to do that as well, and export into either a cold storage, Azure Data Lake, Azure Blob Storage, but also we're working to make the integration closer with our time series offerings like Azure Data Explorer and time series insights as well. Okay, what I want to do now is show you a particular example of Azure Sphere and IoT Central together. Now I'm going to stop the presentation here, and what I'm going to do is pull up my Azure IoT Central. Now, what I want to do, if I go into device templates here, you can see I've got one device template that I've already created. Now, if I just show you creating a new template here, you can see that I've got my Sphere sample device, which is what I created from. But I've also got a huge number of templates here from our partners who have built these devices, and you can see that they're labeled as plug and play. So they've got all the properties defined. So I know when I connect this device exactly what I'm going to get. So a huge number of devices there, lots of different sensor types. So what I'll do, I'll just quickly go back up to here, and I'll go into my device templates, and I can show you here that this one's been created. So you can see I've got some capabilities here. I've got a status LED, I've got a button press, etc., etc. But if I go into devices, what I'll do, let me just see. So I've got one there. What I'm going to do is I'm going to just delete that device because I want to show that being created. Now, what I'll do, let me just move that over there, and I will go to my Visual Studio Code that I prepared earlier. So this is the sample code that I've downloaded. Now, I was hoping to show you another screen feed as well from the Altec camera, but I've been scuppered a bit there. So what I'm going to do is just pull this down here, and hopefully you can see my Sphere device now that's plugged in via a USB cable for power and also debugging. So what I'm going to do, I'm just going to hit start debugging on here, and all being well, this is going to connect to my Sphere device. You can see that's flashing, so something's happening. And then hopefully you can see on the screen that as that image is being deployed, we're starting the debugger now. Hopefully you can still see the main screen as well. So let's just go back to output. And as that application gets deployed, what we should start to see, here we go. Okay, so you can see on there, using DPS connection, we've got a scope ID there. I'm going to talk all through these steps for you. Hopefully you can see now that I've connected and I'm getting some telemetry coming in, so I'm getting some temperature information there. Okay, right, so let me just hold that there for a second. And if we go back into here, let me just open this up wider. So let me go into devices. So now you can see my device has come back in because it's actually been self-provisioned. But what it's done, it's not assigned to a device template yet. So I need to select that. I need to approve that device. And what I'm now also going to do is to migrate that into my device template. So the IoT Central will now say, okay, I know what I'm doing is saying, I know what type of device you are. And I'm just confirming that in here. So if I click on that device, hopefully in a few minutes, so you can see I've got a temperature value in there. We just haven't got much data in there yet to build up a graph. That's going to take a little while. But what I will do in the meantime, just to demonstrate this, if I go to status LED, I can go here and hopefully you can see that. If you look at the LEDs on the left-hand side, I'm going to set that to true and save that. And you can see my LED has come on. So now I could go in and set that to false and set that to false now. So that's gone off. So I want to stress here that that is not happening over the USB cable. This is happening over Wi-Fi through the internet. So I'm not cheating here. Now, that in itself is perhaps not hugely impressive. You know, it's the old make an LED come on and off in an IoT demo, which, as I've said, is not particularly impressive. But what I want to talk you through, and let me just see if we've got some more data in there now. Here we go. So there's the graph coming in there, and we can see the raw data coming in as well. So the thing here is that with IoT Central, I had to do very, very little work to stand this up. And very, very quickly, I've got my Sphere device, which is highly secure, connected in to my IoT solution. And I could connect this device up to a number of physical devices or machines on the back end. So what I want to do now is I'm going to go back to my presentation and I'm just going to start that up from here. Hopefully you can see my screen. So let's start off here. So I mentioned to you about the Sphere device. So the Sphere device I've shown you, that's the physical device. On that device is a unique ID that's burnt into the hardware. That's the hardware root of trust that I mentioned earlier. So that's a very long ID that's burnt physically into the device itself. I mentioned to you about the service running in the cloud for security, and this is the Azure Sphere Security Service. And when you sign up to Sphere, you get a customer tenant that's associated with your Azure Active Directory. And as part of that, you get your own intermediary certificate. So this is a root certificate. This is a root Microsoft certificate that exists for the Sphere Security Service. You get an intermediate certificate that's signed from this certificate here. So we've got our device. The first thing we need to do when we get a new Sphere device is a process called claiming. So your developer will connect your the Sphere device up or as part of factory provisioning, and that UID will get associated with your customer tenant. So now that device is locked to your customer tenant, and that can't be moved. When that happens, a unique device certificate is generated and pushed down to the Sphere device. So that means that we can now use this certificate here that's unique to this device, that's signed by this certificate, that's signed by the root certificate, for authenticating against our IoT solution. Now, in the example that I just showed you, what I did was I pushed an application down to the Sphere device over the USB cable, but in reality, you would do this over the security service, and that would happen over the air. We've now got one of the elements that's sitting under the hood of IoT Central called the device provisioning service. And if you'll notice here, this is an Azure PaaS service. It's one of the PaaS services that I mentioned earlier, but it's built into IoT Central. We've uploaded this certificate, this intermediate certificate here, up to our device provisioning service. And the reason we're doing that is we say, whenever you get a device that contacts you, if they are contacting you with a certificate that has come from or has been signed by this certificate, you know you can trust them. And we can use this provisioning service to register you in IoT Hub. So this is a two-step process. Okay, so we've now got our IoT Hub that I talked about earlier. And again, this is built into IoT Central. There's one of these underneath the covers. And again, you'll see we've uploaded that same certificate because we're saying when a device comes to authenticate, if they're presenting a device certificate that's been signed by this intermediate certificate, we're good to go. So here we go. So when I deployed that application, what happened was that unique ID was sent up to our device provisioning service within IoT Central. And we also sent the certificate to say, look, you can trust me. I've got this unique certificate. The device provisioning service will then talk to IoT Hub and say, right, I want you to have a placeholder, a device registry entry for this device here with this ID. So just expect that this device is going to contact you. Now you can select from a number of different IoT hubs depending on region or from other factors, but the device provisioning service is that single endpoint that you first go to. Okay, so we've now registered the device in IoT Hub and underneath the covers in IoT Central. So now our application can actually contact IoT Hub and communicate. And so you can see in IoT Central where we got our device created where it wasn't there before. So that's a nice example of taking a secure device, a cloud solution, and wiring it all together. What I want to do now, because I think we're good for time, I just want to spend a few minutes, if I may, showing you the HoloLens, because this is really, really quite good if you've never seen it before. And I've got to try and put a HoloLens on over my headset here. That's just about worked. I hope you can still hear me. What I need to do, just fire up the HoloLens. And let me just look around here. Now what I want to do is pull up this and connect to it so you can see it. Okay, so let's do live stream. So hopefully you can see this now. Perfect. Right. So what I'm going to do, I'm just going to walk around a little bit. Now you can see that menu floating in front of me. So this is literally what I can see here. I can just close that down. You are seeing what I can see. So I'm going to open up that view there. I'm just going to show you a few little things that I quite like. So this is a mouse click. I'm doing an air tap here. And I've got a little program in here called 3D Viewer. And what I'm going to do, I'm just going to move this over. If I can just pull that there. Just pull that in. Let's pull that over there a little bit. Okay. Now I'm going to click on, let me see, have I got anything around here already? Right, I'm just going to click on the painting there. So let me pull that out and let me put that, where shall I put that? Perhaps I can put that on the curtains there. Let's see if that works. Okay, so hopefully you can see that. So I've now got a lovely painting of butterflies on the curtains, and let me just pull that down again to there, and then click on that, and hopefully you can see now that those butterflies are actually flying all around the room. Wherever I look, I can see the butterflies in that field of view. So this is all quite sweet and quite fun, but what relevance does this have, and what power does this have to IoT? Okay, so what I'm going to do next, I'm not sure if this is going to be sharing computer audio, so you might not get the full experience, but what I'm going to do is go to another app here, and I'm going to go to the Aviva Holo demo. So what I'm going to do, I need a bigger room to do this. So you have the privilege of seeing my my lounge. Hopefully it's not too messy. This does take a minute or two to load up. So just need you to be patient with me. Again, I'm not sure if you're going to get the audio here, but what I will do, so there's a voice narrating through this process. What I will do, just to double check, I will be telling you what she's saying. And I need a bigger space here because, and hopefully you can still see this. Okay, great. So you'll see why I need a bigger space. I'm just going to close that door there. So I'm going to add here. So I think you might be able to hear that. She's giving me some instructions here. So I'm going to tap the drawing board there. Okay, so I'm going to look at the floor here, and I'm going to put that drawing on the floor just there like that. Okay, so you can see walking to it now. You can see. So you can imagine the power of this with the telemetry from all the devices that I mentioned earlier. Yeah, so for each of the, now I've seen an example. Yeah, I'm going to be fighting our narrator here for airtime a little bit. So now you can see here, if I look actually. You see? So here I am now actually inside. So again, thinking about for each of these devices here, we could be having sensors here, superimposed, so I could see on here, I could see the flow rates, I could see when it was last serviced, I could pull up information about the applications of each piece of kit, and even make a calling to say someone else back at base who was an expert in a particular component if I didn't know what I was doing here. So when you combine all of those things together, you can see what a hugely powerful solution that this is, and this is being used at a number of customers now. So really quite exciting technology. So what I'm going to do is just close this one down now. So I'm just going to close that one down. Okay, so put the HoloLens down and I can close this down. So that's the content that I wanted to go through. We've got plenty of time left, so I guess I would welcome questions, any interaction. I don't know if David is still on.
Yeah, I'm still here, Richard. So we've got a question and answers panel that we can put up. So if anybody's got any questions, please just type them in and I'll relay them over to Richard. I've got to say though, that HoloLens demonstration was phenomenal.
Oh, it's fantastic, isn't it? It's so exciting. When they told us about that technology, it was exciting. But when I got to actually go through the training on that last year and managed to blag one of the HoloLenses, that's a HoloLens 1, so it's the first model. The HoloLens 2 is now out, so that's got an even bigger field of view. It's got intelligent eye tracking. It's another leap ahead, but absolutely to do this it knocks me out every time I do that, to be honest.
I think I went to go on a training course and blag one myself. They
are available. I think the development units, or there may be 2,000 or 3,000, something like that.
Okay, that's I can certainly see how it would be useful. We're in the process of setting a factory up now, and I can see how that would be really useful for the guys on the maintenance crews to go around and, you know, maybe there's a problem with a motor and it could highlight a motor in a different color so they know what one to go to and all this sort of stuff. So yeah, absolutely brilliant. Yeah, like I said, from the start, really, from the sort of technology eye chart that you showed, is interesting to see how you can go from a device to analysis. Security, brilliant with the Microsoft Pluton and the Azure Defender on the IoT Edge. It's great. Got a question just come through. Says, for the HoloLens, are there other use cases, such as in firefighting, that you know of that have been used?
It's a great question. So one of the other things that I can show during the HoloLens demo is for example the human heart, and it will be in front of you and it'll be beating, and you can send it into different heart attacks. So oh gosh, I can't remember the term now. Hypercardiac arrest, etc. Medical is really big for HoloLens. For example, you could be having the scans of a patient and you can see that overlaid on the patient themselves, so MRI scans. You can also have additional consultants from anywhere in the world looking in at the operation, and they could actually draw onto the patient, this is where you need to be going in, or they, you know, I mean, you probably, you know, I'm oversimplifying that there. But that kind of interaction, so they can draw on top of the objects that you're seeing in your real gaze. I think you mentioned the question about firefighting. Certainly, there has been a lot of interest in the military space, which probably won't come as a surprise. I haven't come across firefighting yet. I know they were being used. A big example was at Airbus, for example, where they were putting the seats, layout of the seats, and they were using HoloLens to do the marking, and they saved a huge amount of time, and also improved the quality and accuracy rather than using manual methods. It's being used in all kind of applications. It's fascinating stuff.
And what else have we got? So how do we actually get into this stuff to start off with, Richard? You've got all the IoT stuff. Do we need a big dev team? You know, it's the technology is brilliant, but if you're coming from a standing start, from a traditional IT department, what's the best way to start?
So can I put links in here, because what I would recommend you do. .ms, let me just see. IoT. So if you go into here, there's a learning path. Hopefully you can still see this, where you can get started with all of the different types of technology. Get yourself a free Azure subscription, and you get some free credits for a while, and you can come in here and run through all these labs. And you know, you can do that just through simulated devices. You can pick up these the Sphere device if you want, if you're really interested in that side. They're something like they're about 80 quid for the dev board. There's lots of other dev boards as well that you can pick up for a lot less. You know, I mentioned Raspberry Pis. People are using those a lot, but you can actually learn the technology. For example, in here, IoT Hub. This is all free, so that all this stuff is free. Get yourself a free Azure subscription and just go through all of this learning stuff. You can use Visual Studio Code, which again is free, and you can really get a good idea for how to put one of these solutions together. IoT Central that I mentioned before, you can create an application in IoT Central with up to 2 devices, either real or simulated, for free. So you know, there are a huge number of resources out there to at least get some learning about the technologies in terms of setting up an actual production IoT solution. Obviously, that's a bit more involved. Probably you might want to involve partners in the comms connectivity and perhaps physical device space as well.
Okay. Do you actually need developers to do this stuff, or is it possible for non-developers to do this sort of stuff?
So, I mean, I used to be a developer. I wouldn't call myself a developer now. I can use the tool chains, and I can hack stuff and hack samples and tweak samples up, but I wouldn't call myself a developer. I've recently passed the AZ220 IoT developer certification, but you know, even though I've passed that, I still wouldn't claim to be a developer. Not anymore. You need to be aware of have an awareness of development tools and technologies. I would say that. So you need to be able to use things like Visual Studio or Visual Studio Code. But there are a lot of good samples out there that will walk you through it. So you know, it's not, you don't have to be a hardcore grizzled developer, but certainly some appreciation of dev technologies is required, I would say.
Okay, so you don't have to live in a black room. You can come out and see the light sometimes.
Absolutely, and goodness knows, every time I've tried to actually spend time writing code, I always forget what an intense experience it is and how difficult it is. So yeah, to this day, as always, developers will always command my respect.
Okay. Yeah, I think, you know, it was great. Even the IoT plug and play. There's one request I would have that maybe you could pass on to Microsoft, though. Please, no Vista version.
Yeah, Vista surprisingly doesn't get talked about that much inside Microsoft. I mentioned earlier that a number of factories are still running XP or Windows 7. Funnily enough, the person telling that particular anecdote didn't mention Vista. I don't know why.
Good. Okay, well, I think that's about it for now, really. I have got something I need to pass on to you. So it's a comment came through. I'll email that through to you separately, Richard.
Okay.
Thank you very much for coming along. It was really, really interesting talk. There will be a video, if you're okay with the video on it, going on the BCS website, YouTube channel.
Yeah, that should be good. There's nothing in there confidential that's gone in today.
Okay, so that'll go on the BCS website.
Okay.
So unfortunately, we can't all clap, but I'd love to say I'd love to have a virtual clap for you. Say thank you very much. And
you're welcome. It's just a shame if this perhaps was a few months later, we'd be able to have done this in person, which I am, as I'm sure everyone on the call is. We've all had our fair share of video Teams calls, Zoom calls, and actually looking forward to get in front of other people again in a room. So hopefully that's not too long away now. But thank you to everyone who's attending now or watching on video for spending yet another hour or over an hour on top of a day where you've probably been doing this all day. So I absolutely appreciate you taking the time to watch.
Right. Well, thank you very much. I'll call the meeting to a halt now. There's lots of people saying thank you very much. Everyone's enjoyed it, I think.
Great. You're welcome, folks. Thank you.
So when I shut the meeting down, Richard, unfortunately, it's going to cut it for everybody. So
yeah,
I'll say
no worries.
Thank you personally myself now as well. Thank you, everybody, and hopefully we'll see you again, maybe face to face at some point.
Yeah, sure. I'd love that. Thanks, David. Cheers, everyone.
Thank you. Bye then.
Take care. Bye bye. Bye bye.